Hey guys, welcome to the podcast where I'm going to explain in general our line equation, which right now we're working with y equals d times x, our difference in sequence thought, difference between terms, so what we have to add or subtract from a term to get to the next term. So d times x plus b is our starting point, which is our 0th term or our y-intercept. So this little video is going to explain how we can generalize this equation to all lines and get rid of our difference thought. We are going to keep the y-intercept value, but I'm going to quit calling it the 0th term. But just know that to get the b value out, we have to let x be 0, hence the 0th term. Input is 0. We're going to get out whatever this value is, b. So in class today, this is what we did. I gave you guys 2 points that we graphed, and then you had to figure out the equation that contains these 2 points, the equation of a line that these 2 points are on. So this is what it looks like here. One of our points here is negative 8, 7, right? So for negative 8, 7, and 4, 1. So if we were to input negative 8 into our rule, we know that we'd get out a positive 7. And if we were to put in a 4 into the same rule, we know that we're going to get out a 1, right? So we want to find the equation of this line that contains those 2 points. So what we needed was you guys connected your 2 points with the line, and we found where the equation crosses the y-axis, right? So in this case, we can see that our 0th term value, or our y-intercept value, is 3. So we know that if we input a 0 into our rule, we're going to get out a 3, right, which is what this point is right here. So we know that our b value, or our 0th term value, is 3. So when we write our rule, we know b is 3. So y equals some difference times x plus our 0th term b, which in this case is 3. Now we just need to find our difference, and we'll just take that times our variable, and then there's our equation. Okay, so if you guys look at the graph here, this seems like a nice point right here. Okay, so what that means is from this term, this negative 8th term in a sequence, it looks like we have to actually go over our negative 7th term to our negative 6th term, right? So if we go 2 terms, that means that we drop a value of 1. So what that means is if we increase a term, we're actually going a half, right? Going down a half, which implies negative half. And if we increase that second term, we go the second half, and there's our point. So our difference is actually negative 1/2. So this is our rule for the equation here. So if I were to increase my term number again by 1, I'm just going to go down a half. There's a point on my graph. Increase term value by 1, go down a half, point on my graph. So difference is good. It helps us understand that if we go from term to term, what value that we're adding or subtracting to get to the next point on our graph here, right? So we can continue this pattern, and we get all these points um, in our graph here. So that would be our rule based off of the 2 points. Okay, y equals negative 1/2 x plus b. But now what I'm going to generalize here is instead of thinking of difference, we can actually think about how to get from any 2 points on a line. So how do we go from A to B instead of thinking about going increasing term number and seeing what we add or subtract? If I can just describe how to get from one point on my line to another point on my line, that's really what's important here. So let me show you what I mean by that. I'm going to get rid of this pen stroke here. Okay, so I'm going to click this button here, which is show directions between points. So they're vectors here. So how do we get from point to point? Okay, so to get from A to B, the 2 points that we have here, we can think about direction. This red line that I drew, this vector, is showing us how we can go from A to B. Also, we could think about going from B to A. And to move along this diagonal, we have to figure out the 2 components that are easy for us to figure out on a diagonal move. How do we get from A to B is our question. And if you think about it, it's easy to count vertical movement, like moving up or down, and horizontal movement, because when we think about a coordinate grid, all of our horizontal and vertical movements are scaled, in this case scaled by 1, where diagonal movement isn't scaled, and it's kind of hard to find the actual distance of that. We would need Pythagorean's theorem because we really have a right triangle formed here, right? But to get from A to B, it looks like all we really have to do is go down, going from 7 the output of 7 of A here, right, to an output of B, which is 1, it looks like we go down 6. So if we go down 1, 2, 3, 4, 5, 6, that's our vertical movement to go from A to B. And then we have to figure out how far we go over, right? So we're going from an input value of -8 to an input value of 4. So we have to think, how far is that distance, which from -8 to 0 is a distance of 8, and then we go another 4, so we know that we would go a positive 12. And over here we went -6, right? Now we could think about going from B to A instead of A to B, which is the same thing. We would just, to go from B to A, we would have to go up, in this case, a positive 6 instead of going down a negative. But instead of going this positive 12 from left to right, we're actually going in the negative direction, the same distance, 12, right? We have a nice rectangle when we think direction, okay? So now, if we can think direction as far as how to get from one point to the next as a vertical movement and a horizontal movement, then really that direction is going to be written as a ratio. So let's look at this here real quick. We can actually find the difference between terms in a sequence, or our points that we have. That difference concept that we had, that D for difference, we can actually generalize that as what we call slope of a line. So slope can be thought of as directions to get to any pair of points on a line. So to get to one point to another point on a line here. So that's what we're going to consider slope to be. It's the directions, okay, of how to get there. And slope is going to be written as a ratio of vertical movement over horizontal movement. Ratio just means that we say for every movement we do in one direction, then we write, over the other direction. So in this case, we think about slope here, vertical movement over horizontal movement. To get from A to B, we could think about our slope as being our vertical movement, -6, over, or divided by, our horizontal movement, in this case, a positive 12, right? And if we actually simplify this fraction, since ratios are fractions, that's what we can think of these as, then we can think of -6 divided by 12 is same thing as -1/2, right? If we divide both numerator and denominator by 6, we get 1. 6 goes into 12 twice, right? So -1/2. So our slope, which really is our difference, right? If we went over 1, we'd go down 1/2. But to get from A to B, we could actually generalize that slope to be -1/2, even though we go down 6 over 12. That ratio of -6, our vertical movement, divided by our horizontal movement, gives us this fraction. If we went from B to A, it's the same thing. We still would do a vertical movement of +6 divided by our horizontal movement. In this case, this is a -12. And that fraction still makes a positive divided by a negative. That's still -1/2. So whether we're going from like A to B or B to A, it's the same direction, right? And if we think about slope as a ratio, this is how we can actually find our difference very simply, just given 2 points. Okay, so our slope is going to be thought of as a ratio, which ratio means fraction, of our vertical over our horizontal movement. So when you guys have heard and you say rise over run, this is really what it means. It's our rise, or vertical movement, over run, which means our horizontal movement. Okay, so since we've been using this formula y equals d times x plus b, and slope, which is really uses the letter m for slope. You would think it would be s or something for slope, but actually French mathematician defined slope as relating it to a mountain, right? The French word for mountain is montagne. So really, in our general speaking, because the French guy claimed it, we could think about the slope of a mountain to get from one point to the top, right? Maybe like here's the slope of this section, right? So this is what he meant by slope. Each mountains have different kind of slopes here if we were to think about the graph. So when we think of slope, we use the letter m, which, because a French guy beat us to it, he related slope to mountain. So therefore, the m has the letter, or slope has the letter m for its variable. But that's going to be our generalized difference. So really, slope, or the m variable now, is going to replace our difference in our rule. So instead of talking about difference, even though it's the same idea, we're going to talk about the slope of the line, how to get from any 2 points on our line. And since we only need 2 points to write the equation, we can just figure out how to get from one of the points that we know to the other point that we know. And we're going to call that slope, which really is our difference anyways. But it's more generalized. So then if this is the rule that we were using, y equals dx plus b, our difference times our term number plus our 0th term, or y-intercept. Now we just think of it as in any line, it's going to be the slope, how to, the ratio or the fraction of how we get from one point to the next in simplified form, times x plus our y-intercept value. Okay, so let's see if we can do that for this one here. So here, we're going to write an equation in the form y equals mx plus b that contains these 2 points, right? So basically what we're going to do, we'll do this with GeoGebra, but to graph this point here, this means that we go over 2 in the negative direction, right? We're going to input a negative 2. We know that we're going to get out a negative 12, so we'd have to go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Not drawn to scale, but you can get an idea here. If we input a negative 2, we know we're going to get out a negative 12. That's this point right here. And then we also know that if we input a positive 2, we get out a 0. So that's this point right here. So our line then becomes this guy. I'm just going to extend our bottom here. Okay, so here's our line, right? Basically, and this goes on forever. Should be little arrows on the end. But anyways, we want to write the equation of this. So, we can get that y-intercept value, okay? But for right now, let's find out what our slope is. So if you think about this, our vertical movement, let's say to go from this point here to this point here, what we're doing is if we think vertical, we're going to go up from this y value to this y value. So we're going from negative 12, right, because that's the y value of this point, to 0. That's really a distance of a positive 12 since we're going from a negative up to 0. That's going up a positive 12. So that would be like our vertical change in our y direction. So this is what I mean by slope. Here's our change in our y direction. It's 12 divided by change in our x direction. So to go from this point to this point, we're going to actually run, it looks like, a distance going from negative 2 to a positive 2 is a distance of 4. So we know that our run in this case is 4. So we can think about slope as the ratio of our vertical movement over our horizontal. Ratios are really fractions. So 12 over 4 is how we get to this point to this point. But if we generalize this even further and simplify this fraction, we get 3 over 1 is our slope, or just 3. So in our equation here, we know that we get y equals 3, that's our slope, times x plus, we need to find that 0th term. Well, if I'm going from negative 2 to 0, don't I have to go 2 terms to get to my 0th term? I want to find out what this point is here, right? So it looks like I have to go 2 values going from negative 2 to 0. And if I know my slope, as I go, as I increase my term value by 1, right? This slope is the same thing as difference. I know that I go up 3, right? And if I increase that other 1, I go up another 3. So from negative 12, it looks like I'm going up 3 plus 3, or I'm adding 6 to this, right? So really our 0th term should be equal to negative 6. So with our rule here, we know that our b term, our 0th term, is negative 6, or our rule here, 3x minus 6. Let's do this in GeoGebra and look at a cleaner picture than what I just did. So the first point we have here is if we input a negative 2, we get out a negative 12. So I'm going to clean this real quick. Get rid of my pen strokes. Okay, so now I'm just going to change our points here. We said if we put in a negative 2, let me zoom down here so we can see our points. Okay, so if we put in a negative 2 into this new equation, we know that we're going to get out a negative 12. So that's this point right here. And then we also said that if we put in a 2, we get out a 0, right? So this is the same picture that we drew here. So now if you think about our slope, how to get from A to B, here's how we went up 12 and we ran 4. So the slope is really 3 over 1, or 3. So as we increase value by 1, we go up 3, right, to get to the next point. That's how we find our difference. And notice our line here in GeoGebra, we got that y-intercept of negative 6. So as we increase our slope, if we increase our term value by 1, we use our slope of 3, we go up 3. And then we do that one more time to get to the y-axis, go up 3. There's our y-intercept. of negative 6. So now we have our slope, or the difference, and we have our y-intercept. So that's what we get from our equation. Okay. Um, so that video there is just talking about how we can find slope. Um, these points are nice because I made it so that we get a nice y-intercept. But if we choose any 2 points, slope can be found. To get from one point to any other point, you can always find the slope value. It's just direction, right? So in this case, maybe to go to B to A, looks like we go up from -8 all the way up here to a +6. So really that's a length, or a y difference in the vertical movement of going from -8 to 0 is 8, and then from 0 up to 6 is another 6. So 8 plus 6, we have a vertical movement of 14, and it's positive because we're moving up. And then our horizontal movement would be in this direction to go from B to A. So it looks like we're going from 2 to -5. So 2 to 0 is a distance of 2, and then go out to -5 is another 5. So 2 plus 5 gives us a distance of 7, but it's in the negative direction because we're moving from right to left, right, going in the negative direction. So our slope is just going to be the ratio of our vertical movement over our horizontal. So our slope is going to be 14 divided by -7. It's just our directions, but we can simplify the fraction in this case. -7 goes into 14 -2 times. So we know that this equation here would have a slope of -2. And then if you look in this case, if we have the graph, we can see that the y-intercept is -4. So we know that our rule then would be y equals -2x minus 4. Okay, so these examples gave us some nice points. I want us to make sure that we understand slope, first of all, of how we can really quickly find difference, right? Find the slope value. And then if we have the graph right now, we can just use our line to see where the line crosses. But what if it doesn't cross at a nice 0 a term, or a nice y-intercept value? We're going to have to figure out how we can algebraically find that without graphing. So for instance, like this one, what if we had this point, right? What is that y-intercept value? It looks like -2.5, but we don't know for sure if it's exactly that. So once we get comfortable with slope and we understand that concept, I will show you how we can use our algebra and really these same concepts to find out exactly what this 0th term is. And then if we know, based off slope, how to get from one point to the other one, tells us our slope, and then how we can algebraically find the exact y-intercept, then we can find the equation of any line based off of any 2 points that we have. So this video, hopefully we understand what slope is and how we can use it to write our equations. So see you guys in class. Thank you.